We're moving on from section 8.1. We're moving into section 8.2, which is called proving triangles similar by AA and then squiggle. AA squiggle stands for angle-angle similarity. Now I know it says prove, but that doesn't mean we're doing proofs. It just means we're getting enough information to show that we have similar triangles. Now to show that shapes are similar, based on the information we have so far, we would have to show that every single angle of the shape is congruent to the other one, and every single side is proportional, which means for a triangle alone, we would have to show 6 things: 3 angles, 3 sides. And that gets a little bit tedious. With larger polygons, the things we have to show becomes more. If it's a quadrilateral, there's 4 angles, 4 sides. So all of a sudden you have to show 8 things. Thankfully, triangles are generally the building blocks of what we do throughout all of geometry, and on top of that, triangles tend to have shortcuts. One shortcut to showing that triangles are similar is if you see a triangle in which there are 2 angles of a triangle congruent to 2 angles of another triangle, that is actually enough information to say the triangles are similar. So this is angle-angle similarity, or AA with the squiggle. Really just kind of tells us that if angle A is congruent to angle E, for example, and angle C is congruent to angle D, then triangle ABC is similar to triangle EFD. Now, a couple things about this before we get into the actual examples. First off, it does not matter which 2 pairs of angles. I could have chosen A and B to go with E and F, or I could have chosen B and C to go with D and F. As long as I have 2 pairs of congruent, it fits this. The other thing, when you write out a similarity statement, that's this thing. When you write that out, you have to make sure that you're matching up corresponding parts. And we've been using those matched up corresponding parts for a while. The matched up corresponding parts is what allows us to know that side AB goes with side EF. Now note I'm writing this on the active board because I don't actually want you highlighting this right now. But it's what told us the same with B, C, and FD, for example. They have to go in the same order. So you have to make sure you're matching up sides and matching up angles. When I go to write my similarity statement using angle-angle similarity, I look at my angle marks. I went from the single marked to the unmarked to that one was double marked. Or maybe it would be better if I just did this. And I did the same thing in the other triangle. Single marked, unmarked, double marked. I don't have to go in that specific order. That's just the order I went in. Be consistent with the number of markings on that and the number of markings on this in their places. Okay, so one of the things you're going to start to see is you're going to start to see questions that ask you to determine if you have similar triangles. As we get further into the chapter, we'll have other ways of showing this. Today we're just working with angle-angle. So, what you're going to do when you see this is you are going to look and see if you have any congruent angles. Starting with question A. Are there any angles congruent in this picture? Yep. What angle do you see that's congruent? Okay, that's one pair. I can use my highlighters to help me when it's a right angle. Otherwise, I generally just write the congruent mark. You don't have to use the highlighters for this. Most of the time I don't. but if they help, use them. Okay, that's one pair of congruents. I need a second pair of congruent angles. Do you see a second pair of congruent angles? Not visibly, because the other angles we know are 26 and 64. But there's these angles that don't have anything in them. Could one of them match the other triangle? In other words, is it possible, for example, that this would be a 64-degree angle? Or that this would be 26? And the answer is yes. We can figure that out by knowing things about angles of triangles. Now, Nate, what are you thinking? Being a right triangle does not make the triangle similar. Unless there might be something you're trying to get at, because I know we talked about it quite a bit first try, but it's been a minute. What do we know about angles in a triangle? They have to add up to 180. Those of you who were with me first try, it's been a minute. Those of you who had me last try, we've been talking about this for a while. Angles of a triangle must add up to 180. Because of y'all, some of y'all, it's been a minute, I'm just going to write that little note to self. It's not something that I'm going to do on my homework assignments by any means, but I'm going to write that there so that if you get stuck on a problem, that can kind of help for your notes. So, if angles must add up to 180, how could I find that missing one? Yep. So 180 minus the 26 minus the 90. And we get 64. That is a 64-degree angle. Which means angle E is congruent to angle H. How many pairs of congruent angles do I have? 2 pairs. Is that enough to say triangles are similar? Yes. So I write my similarity statement. Triangle. I'm going to call the first triangle CDE. Remember, when naming a triangle, you got to put the triangle symbol, and then the 3 letters correspond to its vertices. Doesn't matter the order as long as you're going around the shape to get to them. Which in a triangle, that's the only option. Second triangle, I got to match up. Angle C would have to correspond with which angle in the other triangle? K. D would have to match up with G. And E then must match with H. And we know this by angle-angle similarity. So that's the first part of what you're doing today. You're checking for congruent angles. You might have to find an angle if it's not written in. And then you're writing your similarity statement if they're similar. Okay, I'm going to shift over to question B. And yes, I know it's on the very edge of the screen. I just want to make sure that people who are writing this get it down. Okay, question B. Do you see any congruent angles? Angle C is congruent to angle D. They're both right angles. Right angles have to be congruent. The other angles I see are 44 and 47. Is that congruent? No. But do you notice I'm missing some angles? Let's find one of them. Do you want to find A or do you want to find G? There's not a right answer. You just got to make a choice. A, sure, okay. Angles of a triangle still add up to 180. So I can do 180 minus the 90 and the 44. What's the measure of that angle? 46. That is a 46-degree angle. Do we have two congruent angles? No, we do not currently. Finding this angle will not make it congruent. So, these ones are simply not similar. Because angles aren't congruent like they need to be. And that's it for that. Again, just making sure people got this written down before I move on. Question C. Do you see the two triangles in this picture? Sometimes they're a little hard to see for some people. On the overlapping triangles, if you are struggling to see them, one of the things that I tend to do is I tend to outline one of them just with my regular pen, just to kind of make it stand out a little bit more. The one that's hard to see specifically, because most people can see the little one. It's the big one that struggles. Between those two triangles, do they have any congruent angles? How do we know? There's a couple things. There's an open desk at the very back of this room. We're on page 8 of our notes. I'll get you caught up with the part that you missed during work time. Okay, how do we know if there are any congruent angles? That's the question that comes up when angles are not marked with measurements. So, there's a couple different ways that we can know this. And these are things that we did in Geometry Standards A. Option 1, the two triangles share an angle. They share a corner. Do you notice that the two triangles do share a corner in this part? Angle L. Angle L is a part of both triangles. So that is one pair of congruent angles. Angle L and angle L. And yes, I can call them both L because it's the same exact angle. That's the reflexive property in action. Other things that we can use to tell that angles are congruent. Vertical angles. If we have things like two crossing lines, the angles across from one another are vertical. Do we have that in this picture? No. Other things that we can use are parallel lines. Do we have parallel lines in this picture? How do I know the lines are parallel? The arrows. These arrows tell me that I've got parallels, and I just made the arrows not look like arrows. My bad. I meant to just emphasize them. When I have parallel lines, I can have congruent angles, provided they are either alternate interior, alternate exterior, or corresponding angles. So, I'm going to go to the top of my sheet real quick. Parallel congruent angles. We got a couple of options for that. If I have parallel lines being cut by a transversal, the alternate interiors, that's this one and this one, are congruent. That's AIA. Or, if I have parallel lines being cut by a transversal, the alternate exterior angles are congruent. That's AEA. Or, the third option, and I'm going to get you a condensed postulate sheet that has this on it for reminders of things from Geometry A. I'll be honest, I just forgot to print it today. The last option is corresponding angles, which are the ones that look like this. Those setups for parallel lines give us congruent angles. Alternate interior are angles between the parallel lines, but on opposite sides of the transversal, opposite sides of the line going through. Alternate exteriors are outside of the parallels on opposite sides of the line going through, and corresponding. One's between the parallels, one's not between the parallels, but they're on the same side of the line going through the parallel lines. In this picture, we have, for example, this line going through our parallels. And there is an angle from this triangle and an angle from this triangle on the same side of the transversal. Those are, can you tell what kind of angle pair that is? Corresponding. I don't know why I wrote the angle symbol after that, because A stands for angles, but corresponding angles are congruent. That gives us two pairs of congruent angles between the shared angle and the corresponding angles. So, I have two pairs of congruent, so the triangles are similar. Triangle. Let's say I call the small triangle LPQ. I could say it is similar to triangle. What's the big one gotta be called? What letter do I have to start with? L, because that's the shared angle. I went to P next. P was the double marked angle, so now I have to go to J. And the third angle of the big triangle is K. I know that by angle similarity. Okay. Moving on. Question D. Do we have any congruent angles? We do. What angle? Can't call it angle V, but I know what you're talking about. You're talking about this one and this one. What kind of angle pairing are those? Vertical angles. Do we have any other congruent pairs? You have parallel lines. Being cut by transversals. I'll use this one. It makes this angle in the triangle and this angle in the triangle. Those are, can you tell what kind of angle pairing that is? Between the parallels. One's above the transversal, one's below. AIA. That being said, I'm not actually testing that you could tell me they were AIA. If these lines are parallel, though, which they are, you'll have alternate interior angles. I have two pairs, so I could say the triangles are similar. Triangle. First one I'm going to call SRV. It's similar to triangle. What order must I go in on the triangle on the right side? I started at S, so I agree starting with U. Then I went to R. R is this one. So I have to go to T. U, T, V. Again, we know this by angle-angle similarity. We've got two more on this page, and then we're going to change it up a little bit, but the last bit's going to go pretty fast. Question E. Do you see any congruent angles? There's two 52-degree angles. I'm going to mark them. Are there any other congruent angles? I don't have parallel lines, which means I cannot use corresponding.
Is it A and B?
But here's my big triangle, and here's my little triangle. I drew the exact same angle twice. Which angle did the two triangles share? Not A and E, just A. E cuts through the middle of the big triangle, and that's not going to help me. It has to be a full corner of the triangle to be a shared angle. So, my triangles are similar. Triangle ABE is similar to triangle have to start at A, have to go to C, have to go to D. The overlapping ones are the hardest. The ones with the parallels are also the hardest. Otherwise, a lot of them are going to look like this. Final problem on this page. Do I have any congruent angles?
Yeah.
Got a couple of 21s. That one's congruent to that one. I got a 99 and a 61. They do not match. But could the other ones match? Yes. How do I find, for example, angle S? 61 and 21, because those are the two angles in that triangle. I believe you get 98. And if you get 98, what's that mean about the triangles? They're not similar. If you have all three angles in one triangle and two angles in the other, that's enough to see if you've got two pairs of congruent. Okay. Last thing you're going to see today is on the next page, and it's going to look familiar because it's going to continue to come up. It says, use the similarity statements to find the value of x. We're going to skip down to C. These instructions should look familiar because we've been doing them the last couple days. I match up my corresponding sides. FH goes with which one? Make sure you look at the names. FH goes with FL. FG goes with attention. FG goes with FK. I didn't go in order this time. Which means HG goes with LK. I'm just going to leave it unmarked because I don't necessarily need a highlight on it. How do I solve for X? What's my equation going to look like, in other words? Fraction equal to a fraction. It's a proportion. What's one of the things I got to put in a fraction? 11x. The other things can vary depending upon the picture. In this case, it's going to be all four of the things I know. 11x goes over the top of 22 because that's its corresponding side. The other two measurements I know are 24 and 16. Which one has to go on top? Why the 24, Lily? Because it has to come from the same triangle as the 11x. To solve a proportion, I cross multiply. I like to do this problem because of this. Because for some reason, 11x times 16 tends to mess with people because people start to treat 11x times 16 as 11x plus 16. Are plus and times the same thing? How do I multiply 11x times 16? Just do 11 times 16 and put it in front of x. Far too often people try to subtract the 16. It's being multiplied. You can't subtract it. What is 11 times 16? 176x equals 22 times 24? 528. Divide by 176. I don't know what you get. Yeah, three tracks. One last thing I wanted to point out, and I'm literally just pointing it out. We're not even doing the last problem. We are done with homework problems, or with notes today. Just one thing I want to point out. Another thing that I see that messes with people at times comes up in problems like question D. And I had a couple people ask me about it on the homework yesterday. And what people did is they looked at the angles. Have I written a single proportion that has anything to do with angles? No. So, just a quick note. Angles and sides do not mix in equations. They never mix. You're never going to put a side length and an angle in the same equation. It won't make sense. So, that tends to mess with people. So I just wanted that quick reminder. Okay. Today we started 8.2. Day 1. Today's Thursday the 13th, which means our homework is due on Monday. What else is happening on Monday? We've got our first quiz for the trimester. So, make sure we're getting some practice in before Monday on stuff. 8.1 worksheet 1, that's due today. As of right now, I've got your guys' grades updated, or at least more accurately as of this morning. If you turned something in since this morning, it's not in there, obviously.